Hi guys, welcome to Unit 3, Lesson 2, and today we're really going to get into how radians are used and why we have them and all that good stuff. So I'm going to start off with the definition of a sector of a circle. Okay, so I've written in a lot of stuff. So as I said, this is a definition of the sector of a circle. So it's a region bounded by the central angle and it's intercepted by the arc length S. So this right here, that's that sector. This guy right here, we've talked about that. That's the arc length. That's designated by S. And so S, the formula for that, and you guys need to memorize this. So S equals the radius times theta. And on both of these here, theta has to be in radians. So make sure that you know that. Anytime you see theta in like a math problem, so like a word problem or something like that, it's always in radians. So that's why we have to have radians, because degrees is just kind of its own thing. So I put down here that arc length is, when we're finding arc length, that's like our little pizza crust of our pizza. And then sector, that is this whole region in here. So that's like the whole pizza slice right here. And this is the formula for the area to find that. Okay, so let's go to like how this works. So we know that the sector of a circle has an arc length of 16 centimeters and our area is 96 centimeters squared. So we're trying to find the radius and the measure of the central angle. Okay, so we have the area of the sector. So it looks like I'm going to use this one here. Also, we might not be able to start there. So let's start with S equals R theta and see what we have. So S is 16, and we're trying to find R, and we do not have theta. So see, I'm kind of stuck there. So I really feel like I need to use this. So A equals 1/2 R squared theta. So A is 96, and I don't have R, and I don't have theta. So shoot, I'm kind of stuck. So let's go back up here. Let's try this one. Let's see if that one works. So A equals 1/2 RS. So A equals 1/2 RS. So again, we have 96. We're looking for our radius, so we don't have that. But we do have S, which is 16 centimeters. Okay, so see, again, it's just like trial by error here on which function that we're going to use. So literally there's not like a secret, just kind of think about what you have. So I have 96, let's see, half of 16 is 8, divide by 8, so R equals 12 centimeters. Okay, so I've answered this part. So find the radius. I also need to find the measure of the central angle. So this, I think I'm going to come back to that. So I have 16 equals 12 theta. So I'm going to divide by 12. And I get theta equals, let's just simplify it, 4/3. And it says the measure of the central angle. So it doesn't say radians or degrees. So this would be in radians. But if we had to transfer it to degrees, which we have to do somewhat, I'm going to multiply it by 180 over pi, and I end up getting a yucky decimal, and it ends up being about 76.39 degrees. So sometimes it doesn't specify. If it specifies, which it does quite a bit, make sure you're taking it all the way. Okay, now we're going to find the arc length. So I came up with this problem here. And so I just want you to realize, first of all, that the arc length is just this area out here. So I'll probably be using S equals R theta. The second thing I want you to realize is that is not in the proper form. So I have to transfer it to radians. So I'm going to multiply that by pi over 180 and probably have to deal with the yucky decimal. So let me show you. So in my mind, like I'm just, I'm starting out thinking like this, but you can never use degrees. So I have to change that to radians. So I'm going to rewrite this and change this to a yucky decimal. So it ends up being about 2.22. I'm going to keep that whole decimal in my calculator and just go ahead and multiply that by 16. And I get that my arc length is about 35.47 centimeters. Okay, so let's go ahead and do another problem. So this should have been printed on your notes, but it wasn't. So we're going to find the area of the sector, and I have come up with this problem right here. So I think I'm going to start off, really, this is, I know we didn't use it in the last one, but this is the one that's most common. So I'm going to start off there and just kind of see what I have. So we're trying to find the area. I don't know what our radius is, but I know that our theta or our degrees is 36, but remember, there's something wrong with that. We have to change that to radians. So I'm going to multiply this by pi over 180, and I end up getting about 0.6283. I'm going to keep that whole thing in my calculator. But if you'll notice, I'm kind of stuck because I still have two variables. So let's try this. Let's go this route. S equals r theta, because I have S, which is 224. I'm looking for R, but now I have theta. That's 6283.6283. So I can solve for R here. So R ends up being about 356.512-ish centimeters. Again, I'm going to keep that in my calculator. So now I have what I need to bring this up, let's see, right there. So I'm going to push pause and go ahead and do that. Okay, so once I did that, I typed that all in my calculator, and then I end up getting about 39,927.61 centimeters squared. And that's it. Again, notice like I just kind of moved around with what I had, what information I had, and I got stuck, and so I had to go here. So it's just like being comfortable. Again, that's why I want you to memorize these with these formulas here. Okay, so right now we're going to get into a little astronomy. And so we're going to talk about apparent size. And I'm not doing a problem right now. I'm just kind of explaining what it is. So what you're going to do is you're going to be given or either looking for the diameter of an object. And it's going to be, the diameter is going to be the product of the distance between the two objects, and then times the apparent size in radians. So this is what's going on. So we've got this object number 1 right here, and this object number 2 right here. And so I want to point out, if I can draw this, this looks like a preschooler drew it, that this right here, that's your S. And then this is your theta, and that's your radius. So like we've had all this stuff, it just, this application part is a little new, but I just want to point out like this is going to be your S equals R theta. So it's that same formula that we've been talking about. So that's our familiar territory there, even though this part's new. Okay, so I want you to kind of pull out the things that you see in this problem, and just notice that we're going to fit it in this S equals R theta formula. So go ahead and get a head start, and then we'll talk about it. Okay, so this is the first thing I noticed. The diameter, remember, that's going to be our S. This degrees, and a lot of times it will say apparent size. That's going to be our theta, and then how far apart, that's going to be our radius. So I set it up like this, and then the first thing that I noticed is that I can't use degrees, so I'm going to switch that to radians. And so I think you can go ahead and take it from here. So it ends up being this huge number right here, miles away. So if you'll just kind of think about every one of these as an S equals R theta problem, they're really not too bad. So let's go ahead and try this one. So go ahead and just set it up, see what you can do. I'm going to turn you loose on this one. Okay, so on this one, this is our radius. This is our diameter, so that's our S, and then we're trying to find theta. So I set it up just like I always do this, I don't know, just to get my head wrapped around it, even though I knew that this was not going to work. So I knew that there are 5,280 feet in a mile. So I went ahead and figured out how many feet we're going on in that 1.32 miles. So I put that in. So I'm just going to rewrite this as like with my feet in there. And then it becomes a super easy problem. I'm just going to divide both sides by this. Oops. And I get theta equals about 0.0115 radians. And again, if it specifically asks for degrees, then I would multiply that by 180 per pi, and I can do that. And I end up getting about 0.659 degrees. But it doesn't say that, so we don't necessarily have to do that. Okay, so I believe we have one more. Let's see. I guess we have just a couple more here. And we're going to talk about this. This kind of takes a little bit of a detour here. So the first thing that you need to realize is that like lines of longitude and latitude, those are kind of the same thing that we've talked about. So like this is the equator and it's 42 degrees south. So we're going to be down this way. So it kind of has to do with bearings. So here's the thing. We are going to use a formula, S equals R theta, and I'm going to tell you that R is equal to 6,400 kilometers. That ends up being this many miles. You don't need to know that. Like you're either way, it just I will provide this for you on a test if it's needed. So that's not anything that you need to memorize. It's just kind of figuring out which thing the problem is asking for. So I want to start there. So R represents the radius of the Earth. So this stays consistent. So on all these problems, we're always going to use one of these. S is the distance away from wherever you're looking for. So remember, like S, if I wanted to figure out S for the equator and Trig City, it's going to be right here. But the problem said, how far away is it from the South Pole? So let's see, here's the South Pole. So I'm looking for right here. So the first thing that I am realizing is that I don't really need this angle. I need this angle. So let's go ahead and figure that out. So this is 42, 90 minus 42 is 48 degrees. Okay, so that is what I'm going to put, use for that formula. I can't put that in, but that's what I'm going to use. So I have S equals R. I'll just use this one. And then theta. So again, I can't use 48 degrees. I'm just going to have to switch that to a radian. So when I do that, I end up getting this, and then I can just multiply together. So what I just found is the distance between the South Pole and Trig City. Okay, go ahead and do this one and see what you get. Okay, so in this case, we're trying to find all of this. So I need to add the 72 and 43, or sorry, 73 and 42 together, and I got 115. So again, I can't use 115. I have to transfer that to radians. So I'm going to multiply pi over 180, and I get about 2.007. And then when I add these together, I get this, and we are done.